Hello, very good afternoon to every one of you. So we are back in the channel Academy Master, and in this videos we are going to discuss about the remaining part of the previous lecture. Okay, in the first lecture we have discussed about inductive effects, their types, and what are the process of inductive effect. All those things we have discussed there in the first type. In this videos we will be discussing about the electromeric effect. So what is electromeric effect, what are its types, what are the features of electromeric effect, and some examples we are going to discuss about that. Okay, so electromeric effects. So what is electromeric effect? It is the phenomenon of movement of electrons from one atom to another atom in a multiple bond at a demand of attacking reagent is called as electromeric effect. See, one thing is very clear by reading the definitions is that this electromeric effect, it occurs only in a occur only in a multiple bonds. That means what? Electromeric effect you will never find in single bonds. Okay, if the carbon or carbons is linked through a single bond, if two atoms are linked through a single bond, then electromeric effect will not occur there. Electromeric effect will only occurs in those atoms in which double bonds are there. Okay, which is linked through a double bond, like carbon carbon double bond, C double bond O. These are the compounds in which you will see that electromeric effect will take place. Okay, it occurs in a multiple bonds. And what does it mean? It is the phenomenon of movement of electrons. So when this double bond is there, when out of this double bond, if the pi bond is broken, the first bond is called as sigma and the second bond is called pi. So always remember, sigma bond is not broken, pi bond. Okay, movement of electrons when the pi bond is broken. So when the pi bond is broken, there will, as I told you, that one bond is made up of how many electrons? 2 electrons. So when the pi bond will be broken, the electrons will be released. There will be release of 2 electrons. Now the movement of these electrons, okay, to another atoms, the movement of these electrons to another atom can be here also, can be here also. Okay, so the movement of these pi electrons to another atoms, why they are moving it, why this bond is getting cleavaged or getting broken? Because on the demand of attacking reagents, the attacking reagents wants these bonds to be broken and the electron has to be shifted to other atoms. On the demand of that attacking reagent, this bond is broken. Okay, broken, and the electrons are shifted to the another atoms. So this phenomena of breaking a pi bonds, okay, in a multiple bonds and shifting the electrons to another atoms on the demand of an attacking reagent, we call it as what? We call it as electromeric effect, or we call it as, this one is also called as E effect. Okay, in short we call it as E effect. Got it? So what are the features of this electromeric effect? Let us see. It is a temporary effect. That means what? This effect is not permanent. Like inductive effect we have seen, it was permanent effect, but this effect is not permanent. If it is required, it can come back to the original position also. Got it or not? So that's why it is called as what? Temporary effect. Next thing, it takes place between the two atoms attached by the multiple bond. This electromeric effect, you will basically find that it will take place only among those compounds in which multiple bonds are there. Multiple bond means either it has triple bond or it has a double bond, but single bond, in single bond it won't work. Okay, fine. Electromeric effects are two types. There are two types of electromeric effect. Okay, one type is what we call it as positive electromeric effect or plus IE effect. Positive electromeric effect or positive E effect. Okay, so what does it means? When the electrons of the pi bond are transferred to the atom to which the attacking reagent finally gets attached, then the effect is called as what? Plus E effect. So what is it? Let us try to understand with the help of an example. Suppose these two are double bond. Okay, now you see here, when the bond is, and this is an attacking reagent. Okay, so I have written here attacking reagent. On the demand of this attacking reagent, what will happen? The double bond between these two carbon, it will be broken. Okay, and the electrons which is released by the cleavage of pi bonds, it will be shifted towards this carbon. Okay, so the electrons is getting shifted towards this carbon, and fortunately electron is getting shifted towards this carbon, and fortunately the attacking reagent is also going and get attached with this carbon. Okay, that means the electrons, after the cleavage of bond, this carbon is getting the electron, as well as this carbon is getting attached with the attacking reagent. So if this is the case in which the same atom gets attached to the attacking reagent also, and the same atom get attached to the electrons which is released by the cleavage of double bond, then that effect we call it as what? Positive electromeric effect. See here, after the reactions, this carbon has lost the electron, so positive charge, and this carbon has gained the electron, as well as this attacking reagent also is attached to the same carbon. The carbon which is gaining the electron, same carbon is getting attached to the attacking reagent also. So that kind of electromeric effect, we call it as what? Positive electromeric effect. I hope it is very clear, dear students. Okay, now let us go to the next, the second type. The second type is what? Negative electromeric effect or minus E effect. Okay, yeah, so negative electromeric effect or minus E effect. So what does it means? Now here, when the pi bond is broken, the electron is getting attached to the carbon, and the same carbon is getting attached with the attacking reagent. But in negative electromeric effect, what will happen? After the cleavage of the bond, double bond, the electron is moved towards oxygen. Okay, in example you see here, the double bond between carbon and oxygen is there, and after the cleavage of double bond, the electrons is getting added to the oxygens. But the attacking agent, that is negative attacking agent, okay, this negative attacking reagent, it will go and attach to the carbon. Okay, it is getting attached to the another atom. It is not getting attached to the carbon which, or to the atom which is getting the electrons. The atoms which will get the electrons, that atom, it will not be getting attached with the attacking reagent, rather the other one will get attached with the attacking reagent. Okay, here, by the cleavage of double bond between carbon and oxygen, oxygen has got the electrons. Okay, after the breaking of a pi bond, the electron is shifted towards oxygen, because oxygen is more electronegative, and the attacking reagents goes and attach with the carbon. Why? Because after losing the electrons, the carbon gets partially positive charge and oxygen gets partially negative charge, but Cn is negative. So Cn will never go and occupy, never go and attack the oxygen, that is negative. Negative, they repels. So Cn will go and attack the positive part, that is C positive. So it will get attached with the carbon. That means here one atom is getting attached to the attacking reagent, one atom is getting, and another atom is getting attached with the electrons. Means both are different. Electron is getting attached to another atom, and attacking reagent is getting attached to another atom. So this type of electromeric effect, we call it as what? Negative electromeric effect. I hope, dear students, you have understood this all topics. It is very easy. Okay, take it down the notes, and then we shall move on to the next topic. Okay. Okay, so now we are going to discuss about the difference between inductive effect and electromeric effect. Inductive effect already we have discussed in the earlier videos lecture. If you have not watched that videos, then please go to my channels, Academy Master and Chemistry Class 11. You can watch there, chapter number 12. Okay, so what is inductive effects and electromeric effect difference, we are going to learn now. So first difference is what? Inductive effect. I'm writing in a short, very short. Okay, that is also okay, you will get a marks in the exam. So what is inductive effect? It is a permanent effect. Inductive effect is what? Permanent effect. Okay, and electromeric effect is what? It is a temporary effect. In inductive effect, you will see that the electrons are getting transferred and it is permanent, it won't return back here. But in electromeric effect, just few minutes before we have discussed that it is temporary effect. Here the electrons can come back to their original position also. So it is called as what? Temporary effect. Number 2, it occurs in a saturated compounds only. Inductive effects, it occurs only in a saturated compound. Saturated compound means those compounds which contain a single bonds. Only in that compounds the inductive effect will occur. Whereas electromeric effect, it occurs in unsaturated compounds only. That means inductive effect, electromeric effect, it will be occurring in those compounds which contain double bond or triple bond. Okay, it won't occur in a single bond, that is saturated. Okay, it does not need any outside reagent for its operations. So electromeric effect does not, inductive effect does not need any outside attacking reagents for the reactions to occur. Whereas in electromeric effect, you will see that we need an outside attacking reagent in order to operate the, okay, in order for the reactions to take place. So it operates only in the presence of outside attacking reagent. Got it? Okay. Now, resonance or mesomeric effect. The third type is resonance effect or mesomeric effect. So what is the resonance effect? Let us try to understand, read the definitions. If a molecules can be assigned, molecule can be carbon dioxide, H2O, anything. So if a molecules can be assigned two or more structure, those molecules which can be assigned two or more structures, okay, none of which is capable of describing all the known properties. Suppose we have assigned two structure of it, carbon dioxide, but both the structure, they are not able to give the complete information or give the complete properties of that carbon dioxide, none of which is capable of describing all the known properties of the compound. Then the actual structure, then what we'll say, the two structure, the new structure we have drawn, you can see here down, second and third one is the two new structure which we have assigned, but this second and third, it alone they cannot explain the all properties of carbon dioxide. So actual structure, that is the first structure, is called as what? Then the actual structure is intermediate or resonance hybrid of this structure. So the actual structure number 1 will be the resonance hybrid of the remaining two structures. Okay or not? So this effect we call it as mesomeric effect, or we call it as what? We call it as resonance effect. Okay. So see here, number 1, the structure number 1, carbon dioxide plus structure number 1, it is the original structure. Then we can also draw the same structure in this way. This one will tell us something, some property. It will tell us about some properties of the compound, like triple bond. Here the bond length will be less. Okay, again here also triple bond, so here also bond length will be less. But this one, the first structure, does not tells us about the triple bond. It only tells us about the double bond, and in double bond the bond length will be little bit lengthier than the triple bonds. Okay, so these three are the resonating structure of carbon dioxide molecules. Okay, dear students, so this is all about your resonance and mesomeric effect or mesomeric. Now after taking down this one, we will be studying about the types of resonance or mesomeric effects. Okay, take it down all of you. Okay, dear students, now we are going to do there are types of resonance or mesomeric effect. Okay, before I start with, dear student, I want to tell you the importance of these topics. Okay, so there are 5 topics under the electron displacement in a covalent bond. First is inductive and its type. Then second one we have done is what? Electromeric and its type. Third one we are doing resonance and its type. Okay, remember, out of these 5 topics, one topic is confirmed, it is coming in your board examinations, and for CBSE your yearly examination. Surely it will come either for 3 marks or for 5 marks. So dear students, this chapter, this sections, electron displacement in a covalent bond, is very important section of this chapter. So all of you, please try to concentrate, try to understand properly, and these are basic points. Okay, these basic points you will be needing it in class 12 organic chemistry also. So dear students, I request all of you that try to understand properly, try to study the things properly. Okay, fine. So let us start. And those who have not watched the video lecture on this chapter 1 in chapter number 12, video number 1, 2, 3, 4, don't forget to go to my channel Academy Master. There you will find all the notes, explanations related to IUPAC naming and other part of this chapter, functional groups, and all these things are there in the Academy Master channel. Okay, you just have to subscribe it, and you can watch the videos free of cost, take down the notes free of cost from there, and learn it during this pandemic. Okay, so type of resonance or mesomeric effect. So first one is what? The first type is what? Positive resonance effect or mesomeric effect. We call it as plus R effect or plus M effect. Okay, both are the same. So what is it? If the substituent has a tendency, what is the substituent? Already these things we have discussed in the videos number 5 or 6. You can please, if you forgot, you can again visit it and you can see the videos. If a substituent has a tendency to donate electrons to the double bond or a conjugated system, then the effect is said to be positive resonance effect or positive or R effect. Okay, so see here, what does it means here? If the substituent has the tendency to donate, that means the substituent which are present, it has the capability to give its electrons to the other. So when I give electrons to Mr. X will gain the electrons. So for example, let us try to understand in a simple way. Okay, suppose I am working in institutions. So that institution is paying me the salary. So with that salary, I am paying the salary to my employees, and my employees again feeding to their families, right or not? So both are interrelated, or all are interrelated or not? Same way here, if the substituent which is present here, the substituent is this one. Okay, the substituent which is present has the tendency to give the electrons to the double bond. Then one substituent will give electrons to one carbon, that carbons will be given to the next carbon. So entire compounds will be affected with this. So see here, CH2 double bond CH single bond Cl. So Cl has the tendency here, Cl act as the electron donating compounds here. So Cl is giving the electrons to this. So when Cl gives the electrons, always remember the person who gives the electrons or loses the electrons, they get a positive charge. So Cl will get a positive charge, 2 electrons is given, so here one double bond will be formed. Here double bond is formed, and because of the formation of double bond here, this double bond has to be broken and it will be shifted to the another carbon. So this double bond is broken and electron is shifted to this in the form of a lone pair, and since this carbon has gained the electron, so it will get what? Negative charge. Okay dear students, so this is called as what? Positive resonance effect or plus R effect. Okay, got it dear students? Hope it is clear. Okay, next moving on to the type 2, that is B, negative resonance effect or minus R effect. So by the point itself it is very clear. Negative resonance effect or plus minus R effect means the electrons will be pulled out from the compounds. So let's see, if a substituent has a tendency to withdraw electrons from double bond, now the substituent which is present, it should have a capability to withdraw the electrons. Okay, they are now not donating the electrons, they are not giving the electrons. Okay, they will take the electrons from the compounds. Okay, has the tendency to withdraw the electron from a double bond or conjugated system towards itself. So this substituent which is present, it will withdraw the electrons towards itself rather than it will donate. Okay, so towards itself, this effect is called as what? Resonance effect or minus R effect. This effect is called as negative resonance effect or minus R effect. Okay, so here it is CH2 double bond CH single bond C triple bond N. Okay, so you can see here clearly, here CH double bond, this double bond is broken and the electron is shifted to the next carbon. So since this carbon is losing the electron, it is giving away the electrons, so it will get what? Positive charge. okay, and here the bond will be single since it is broken and the electron is shifted to the next. So the electrons is coming and it will form a bond. Here is a single bond, but after the reaction you will see that there will be a double bond. Now this triple bond will be broken, only it will be double bond, and the electrons will be given to whom? The nitrogen. That means this Cn, it is pulling the electron towards itself or not. So Cn is called as what? Having the electron withdrawing group. And since Cn is gaining the electron, 2 electrons, earlier it has only 2 electrons, again 2 it has gained, so see 2 to 4 electrons and plus 1 negative charge. Always remember, the person who gains the electron, they always get a negative charge, and the person I'm telling, the atoms, and the atoms who give away the electrons, they gain a positive charge. So this phenomena we call it as what, or these reactions we will call it as minus R effect. So dear students, it's very easy, very simple. Try to understand the basic things. Then some of you might be preparing for JEE, NEET and all. You have a target of becoming a doctor, engineers and all. But dear students, for becoming doctor, engineers or whatever your ambitions are, very good, I appreciate, and it's very good. But first of all, some of the, I don't want to take the name of the institutions, some of the institutions are there, some of the channels are there, so they are only teaching the very high level things without teaching the basics. Though that is a big mistake. If you don't know the basic grassroots level things, and directly if you try to catch up with the high level thing, it's very difficult. Okay, so for that I request all of you to build up your basic with the help of this channel. I'm teaching you in a basic way, basic things, then you can think for your higher studies, not only in chemistry but physics, maths, bio as well. Okay, now take it down. Next we will move on to the difference between inductive and resonance effect and all those things. Okay. So now we are going to discuss about the difference between the inductive and the resonance effect. Okay, so since the video is getting a little lengthier, so with this I will be winding up. Okay, so difference between inductive effect and resonance effect, inductive effect and resonance effect. So first difference is what? This effect involves the displacement of sigma electrons. You will see that in inductive effect there was a displacement of sigma electrons because single bond is broken. So whenever single bond is broken, that is sigma bond is broken, that means sigma electron is displaced. But in resonance effect, right now we have seen this effect involves the displacement of pi electron. Here double bond is broken, so double bond, the first bond is always pi, so here pi electrons is displaced. Pi electrons will be moving here and there. Here it will be sigma electrons. Okay, next, it operates in a saturated compound. So we know very well inductive effect occurs only in a saturated compound, means those compound which has only single bond, means alkane. Okay, resonance effect, it operates in unsaturated compound, means unsaturated compound means those compound which will have double bond or triple bond, or we can say in other language multiple bond, or you can say that it operates only in alkene and alkyne, whereas this one operates only in alkane, that is saturated. Okay, third point of differences here is this effect moves up to carbon atom, move up to 3 carbon atom, then becomes negligible. That means what? This effect, inductive effect 1, 2, 3, 4. That means what? In inductive effect you will see that the movement of the effect, okay, movement of the effect, it will be up to 3 carbons, and after that it will be there but negligible. It is equivalent to 0. It's just very less. Okay, but here in resonance effect, this effect moves along the length of the conjugated system, means it will be moving on how lengthy the bond is, how lengthy the compounds is. It will be going on moving, and this effect never ends up. Okay or not? So this whereas inductive effect, you will see that after 3 carbons it becomes negligible, whereas resonance effect, it will go on moving along the length of the compounds. Got it or not? So this is the basic difference between inductive effect and resonance effect. I'm trying to make it very simple for you guys, okay, so that understanding will not be a problem for you guys. That's why I'm trying to make it very simplified notes and very simple, specific, so that it won't be a trouble for you. And dear students, Again, I'm telling you, chemistry will be very fun. Learning is very easy, very nice. You will score good marks also, provided be very sincere. Try to learn the things from the channel properly, okay, and try to make a note. Making note is very important. Again, I'm telling you, because dear student, if you don't make the notes, then in the exam time, if you're writing in a piece of paper, you will be searching that paper, where is there, okay. So that one will create a problem for you. If you have a notes in a systematic way, how I'm giving to you, in the exam time it is very easy. Oh, this one I need to study, okay, it will be there in that page, done. So it is very simple, okay. So that's why I'll request all of you that you try to make a note, maintain one notebook, okay, of chemistry, okay, so that it will be easy for you to understand and easy for you to maintain the record, and whenever it is needed you can refer it, okay. So there are a few more, and don't worry about the syllabus coverage, okay. Others teacher might be covering 4 chapter 5 chapters and all. Don't worry about chemistry. I assure you that entire syllabus will be done here. Don't worry, okay. Before your final examination we will cover up the entire syllabus, but for time being what you have to do is you have to go on steadily, because these chapters are very important. You need to understand the concepts first, and so slowly steadily we will go, okay. So we'll finish up these chapters after 4 5 maybe 2 or 3 videos. We'll finish up these chapters. That is our chapters 12 will be over, class 11 chemistry, and then we'll be switching on to another very important chapters. I'll be telling in the later part, okay. And dear friends, dear students, if you have friends with you, so don't forget to share these videos with at least 5 of your friends, okay, who are known to you or unknown to you, okay. Share these videos to them so that they also can get the informations about these videos, and through which they can help to others also, okay. So here I'm signing off, okay. And don't forget to subscribe my channels, and if you are new to the channel, so that you will get the notification on time and you can watch the videos properly on time without any delay, or else others friends will be writing notes and will be done with the explanation, and you will be lagging behind if you don't subscribe the channel. So, and share the video and like the videos, okay. Thank you very much. Have a great day ahead.